The starting point, like many good things, it started with a cardinal sin. In that case, it was Roland committing a cardinal sin in design. He combined two elements of the two preceding chair lines that we designed. One is the torsional flex of the spine, and the other one is the continuous surface.
So this is the connection. Here you can see still that's a mirror part, and this is a C2 beam.
When it comes to the structure of the chair, this is the essence, because it is the synthesis of the frame and the spine in one part. That is what makes the chair work, besides from the tilt.
We are in the form finding camp, not in the form giving camp.
We try to listen to the form, what it wants to be.
In German you say Entwurf. Entwurf means design, but it says you throw something. So you throw something a little bit ahead of the curve in order to...
Ahead of what you know. Actually.
What you know, in order to help you pull you in the right direction. So this is the design part of it, and then the exploration goes on, and it's a push-pull between the two. Clients need to be much more patient with you, because you almost reject to show a fancy rendering in the beginning. But you say, the vision is like a flying carpet. And this is transporting then, or helping you as a guiding principle down the road through manufacturability, performance, integrating everything according to that bigger vision. But it's not that we have a final shape in the beginning to start with.
We learned it the hard way when we introduced the Mirror One, and we demoed the chair that people simply don't use their controls.
The reason they don't use the control is that they don't even know what the objective is, while everybody that designs the chair, they know what the objective is. So we thought, why don't we put that knowledge into the box instead of putting that burden on the user?
A tilt to a chair is what an engine is to a car. We wanted to build an engine for a chair that is fully automatic. That's the rationale behind this thing. The trick is that this is the so-called fulcrum, and that should move. Yeah, see, it's still working.
If you're heavy, you sink in more and create more force output.
This is the only thing where all the ergonomists can agree upon. Change is good. So you should have a chair that allows you to change your posture as often as possible. So go full back and recline, take pressures from your disc, go upright again, be involved. And you can only do that if you got a chair that is correctly adjusted. And since nobody adjusts their chair, we wanted to help them to build something that does this part automatically. A performance task chair, or a very good chair as we think about it, is mainly defined by two things. One is the dynamic, and the other one is the kinematic. The kinematic is how the chair moves. And a chair should move with you. So if you go back, it should open between your legs and your back where your pivot points are, so right at the hips. If it's not moving like that, you feel shear and it's uncomfortable. And so you always try to move back and take pressure from your discs. So this is one thing that the tilt defines. And the other thing, the dynamic, is how it feels if you go back. So sometimes you have to push, sometimes it's too light, then you feel insecure, but to be balanced for any user, that's like the holy grail of building the perfect chair. This one is so special because it has this scale belt. So if you sit down on the chair, you press this down, and while you press this down, this fulcrum that normally has to be adjusted by hand is adjusted automatically. So a mechanical solution for something like this is just more reliable over time. So that's why we said no sensors, no electronics, just a mechanical, rock-solid solution to balance people.
On our chairs, there is no such thing as an invisible part. You can actually see everything. Maybe some things within the tilt box are not visual, but anything else in the structure is visible. This is what engineers call a beam, and what we do with the whole chair, we orient it always so that it lends itself to bending, and here it's stiff again. So, and here it's also stiff because it's in a diagonal. It has a lot more truss height than here. This has almost no or very little truss height in that direction. So you can easily bend in this direction, while this cannot bend. And that is a play that you see in the whole chair.
And this is the granularity we are talking about right now. So this is the final idea, to have spine and beams as one part.
It is so final, it even has a Herman Miller logo on the rear side.
But still no textures. So this is pretty much from here to here, it's 7 years.
My favorite reaction would be if they would, if they would forget the chair. If it were so good that they actually would only feel what they're doing at that moment and totally concentrate on it. In English, there's this expression, to lose yourself, you know?
There's a pride of having the best tools, and because it's a pleasure to use them. And this is the joy we want to give. It should be a pleasure to use it, and it's like appreciation that you are a hardworking knowledge craftsman, and you deserve the best tools that are there to support your work.
There was also a membrane invention. You control really where every single thread is. At the same time, while these were all sittable prototypes, there was this whole line of work was in parallel, where we worked on the sculptural quality of it and how to manufacture it. And one of the biggest challenges, or of the biggest opportunities, was how to attach this membrane and how to make the membrane blend into the frame as seamlessly as possible.
I brought this little piece that I would define as alien spit. It looks a little awkward, but I think it shows our MO, the way we work, and it was really essential to dynamically develop our prototyping techniques along the challenges of the program. And so by developing this technique of casting rubber, we were able to develop this frameless membrane. And so the first attempts to do so looked more like this. Kind of interesting. No? Yeah. Here you can see this is a B-colored one that would be a future CMF option maybe, but this reflects the sophistication of the molding process. Actually, the gray layer is molded first to capture all the membrane fibers, and then the top layer is added later in order to secure that we have a perfect shutoff between the edge and the membrane and perfect rim conditions.
The nice thing about this low back is that the relation between the frame and the membrane is actually so that not only do I not feel it when I recline like this, because I'm not in contact with it, it's also when I sit sideways and sit like this, I don't feel it either. It's actually very comfortable to sit like that. If you're working, your hands are actually on the table.
Or on the device.
Or on the device. But what you really need is a place to rest your elbow. And since the elbow is a very delicate part of our autonomy, it really wants to be placed in a very soft but yet
firm spot.
A firm spot. And so over the evolution of this, the arms really became a sling where you cradle the elbow in.
So this is one of the first models, and here you can see that we're really in the form finding business. This is the idea of first creating and answering a need and an observation, and then developing it through different iterations, landing here. That's the evolutionary process, and that's what it takes. If you sit, you really want to be supported with your elbow because you carry something. You might check your emails or Twitter. Once you go closer to a table, normal armrests are in the way. You need to shuffle them out of the way. Here, the idea is that you are able to cradle your elbow and then have your palm on the table. And this then creates the perfect support system for your arms. CMF, or color fabric material, is always one more dimension, and at least if you look at this display, it looks like fun. The membrane material is not a fabric, but a construction. The monofilament, where the people are sitting on, so to speak, that's a graphite yarn. It's a delicate construction, and going to a slightly coarser fabric helped to create a credibility for the construction. This is like one half on our side, one half went to the US in order to make sure that we are looking at the exact same.
Or talking about the same thing.
Because color is a very delicate topic. Sometimes even structurally, white beam is not as strong as a black beam. Of course, it has more pigments to it, and that reduces the structural integrity. So color is even structurally an important factor. You need to almost control the pigment before it goes into a paint or before it goes into a molding process, so that at the end the color looks the same in every lighting condition. That's the tricky part.
The coloring, or the monochrome coloring, dematerializes the object. It is made out of many different metals, out of many different plastics, even fabric, but in this stage it's just the red thing. There is a seamless integration of the membrane to the structure, so it all should feel like one thing, like an organism that grows more soft and pliable in this area and has thicker cross sections and is harder there, but really shouldn't be about that we attach this to that. Okay, that's important for manufacturing it, but in the perception for people, it should be one thing.
Yeah, we never wanted to make another chair. We really wanted to make a flying carpet. And so this was our working title for the program. We want to create a flying carpet.
Yeah, you have to make up. Every project has a project name, and the project name will not be the product name. And that, of course, was one that both sides of the Atlantic could agree on.
Because it's also programmatic.
Yeah,
it was a description.
It was a description of
flying zero gravity.
What we wanted to get. Yeah.
We wanted to create perfect equipment for knowledge workers.
We worked very hard to make sitting easy for you.
So you can just sit down and forget about gravity.